The purpose of differentiation is to give you a gradient function. For example, the gradient function of y equals x squared is 2x. This means that the gradient at 1, 1 is 2, at 2, 4 it's 8, at 3, 9 it's 6, at 15, 2, 2, 5 it's 30, i.e. it's 2 times x, and so on. This video will look at the process of differentiation and then give an example on finding the equation of the tangent and normal of a cubic curve. A tangent is a straight line which touches a curve at a point with the same gradient as the curve at that point. Hence we can use differentiation to find the gradient of the tangent. A normal is simply a line perpendicular to a tangent. It is assumed that you are able to write terms in index notation. If you need extra practice, follow the link to the indices video below. Firstly, notation. When we differentiate a curve such as y equals x squared, the differential is written as dy by dx equals 2x. Let's look at the process. To differentiate a term in a polynomial, you multiply the term by its index and then subtract 1 from the index. Remember the acronym DMSIAD. Don't meet someone in a disco. DMS stands for differentiate, multiply and subtract 1, and IAD stands for integrate, add 1 and divide. Before differentiating a term, you must ensure that it is written in index notation. Now we shall look at some basic examples. Applying the rule multiply the term by its index and then subtract 1 from the index, we find that the differential of 7x cubed is 21x squared. The differential of 4x is 4. If you think of the 4x as 4x to the power of 1, we multiply 4 by 1 and then subtract 1 from the index of 1, leaving us with 4x to the 0, which is 4 times 1, or just 4. In general, the differential of ax is a. The differential of 6 is 0. Think of the 6 as 6x to the power 0, so that we multiply 6 by 0. Altering the index won't change the fact that the final answer is 0, and in general, the differential of a is 0. On the following slide, we look at terms which need to be rewritten in the form ax to the n before we can differentiate them. The square root of x is x to the half, and the cube root of x is x to the third. 8 over x squared is the same as 8x to the minus 2, and 6 over root x is the same as 6x to the minus a half. Once each term is written in index notation, we can apply the rule. Now for an example on finding the equation of the tangent and normal. A curve has the equation y equals x cubed minus 2x squared minus 5x plus 2. Firstly, find the equation of the tangent and normal at the point where x equals 3, and then find the other point on the curve for which the tangent is parallel to the tangent in part 1. Strategy. Start by differentiating the curve. Then substitute x equals 3 into dy by dx to find the value of the gradient, and into y to find the y value of the point. Next we use the formula y minus y1 equals mx minus x1 to find the equation of the tangent, and we use the perpendicular gradient to find the equation of the normal. For part 2, we put dy by dx equal to the gradient found in part 1 and solve. Here is the solution. The differential is 3x squared minus 4x minus 5. Substituting 3 for x, we find that dy by dx is 10. Substituting x equals 3 into the original equation gives us y equals minus 4. Now we can find the equation of the tangent using x equals 3, y equals minus 4, and m equals 10. It's y equals 10x minus 34. For the normal, the gradient is minus a tenth. Use the same values for x and y, and we get an equation of x plus 10y plus 37 is 0. To find the other point with a parallel tangent, we put dy by dx equal 10 and solve the equation. So we get the equation 3x squared minus 4x minus 5 equals 10, which turns into 3x squared minus 4x minus 15 equals 0. Factorising, we find that x is either 3, which we've already got, or minus 5/3.